Welcome to clickmyproject.com. Our project title is Detecting Colluding Blackhole and Greyhole Attacks in Delay-Tolerant Networks. Abstract. Delay-tolerant networks is developed to cope with intermittent connectivity and long delay in wireless networks. Due to the limited connectivity, DTN is vulnerable to blackhole and greyhole attacks in which malicious nodes intentionally drop all the packets that is received messages. Although existing proposals could accurately detect the attacks launched by the individuals, they failed to tackle the cause of malicious nodes cooperated with each other to cheat the defense system. In this paper, we suggest a system called statistical based detection of blackhole and greyhole attacks to address both individual and collision attacks. Nodes are required to exchange their encounter record histories based on which other nodes can evaluate their forwarding behaviors to detect the individual misbehaviors. We define forwarding ratio matrices, then can distinguish the behaviors of the attackers from normal nodes. Malicious nodes might avoid being detected by colluding to manipulate the forwarding ratio matrix. To continuously drop messages and promote the matrix at the same time, attackers need to create fake encounter records frequently and with high fogged number of sent messages. We exploit the abnormal pattern of appearances, frequency and number of sent messages is fake counters to design a robust algorithm to detect colluding attackers. Extensive simulation shows that our proposed system can work with various dropping probabilities and a different number of attackers per collision at high accuracy and low false positive. Let us see the flow of our project. First, in our project we have to design our DTN network model. So our delay tolerant network model contains a number of mobile nodes which is moved randomly. So for that we have to use random mobility model technique. These nodes are sensing the range. After sensing the range, it will calculate the misbehavior nodes using our SDBG scheme. So this identify the black hole as well as greyhole attacks. First we have to identify that detecting individual attacks using the threshold values. If once the individual attacks are detected, we have to also find the colluding attacks which sends lots, which drop all the lots and lots of packets from the source. If all these attackers are detected, we have to send successful transmission using our SDBG scheme. Using this SDBG schemes, also we have to evaluate our performance using packet delivery ratio, false positive ratio. We also compare our false positive rate with the existing system. That is, in existing system is contains MDS technique. We have to compare that technique through our proposed SDBG system. So our SDBG system gives a less false positive rate than the existing system. Let us see the output of our project. First, for running our project, first we have to open the VMware workstation. In that, click this terminal window. So first change the directory to our coding folder. For that, cd space our folder name, cd space, cd is nothing but changing directory to our folder name. So cd space our product, cd space then our SDBG. So this is the line for running our TCL file. That is, this is our syntax, that is ns space main.tcl. When we type this, it will produce what are all the factors used in our SDBG scheme. So this is our output window. this is denotes a number of nodes we have to use, and this will produce one output window called a NAM window. So this NAM window contains number of nodes and this moving speed buttons. When we click on this play forward, it will works. So we have to set 8 as source node and 13 as destination node. So our process is a mobile network, so all the nodes are in random mobility model. Our process is detecting statistical based detection of black hole and Greyhole attacks, which can detect both individual and collision attack with high frequency. So now all the nodes are in a random mobility model. So first, STBG is designed based on the individual attacks, which forwarding the ratio defined above can be used. So now the individual attacks can be detected. So now it will transmit the information via this neighbor node 18, but this neighbor node 18 is act as a malicious node, and it will drop all the packets, which leads to that destination can't reach all the information which is sent by the source node. So now all the packets are dropped by the neighbor node, that is node 18. So this is called the individual attacks. So now we have to select another path for sending the information, sending the data packets. Now the neighbor node 6 can send the information to the it will receive the information. So now it sends the information to the node 2, which is also act as a Greyhole and Blackhole attack, that is colluding attack, and it also drops the packets which is received from this neighbor node 6. So we have to identify both individual and colluding attacks used implemented by using statistical based detection of black hole and Greyhole attacks. This scheme is used for detecting these both attacks. So now we have to detect these two attacker node, and we have to send the information. We have to take another path and send the information securely to the destination 13. So now the path is taken as 4 and 3 and 0 and 13. This is our NAM output screen. For performing the evaluation, we have to run our graph file. So just close it. And in once again go to the terminal window and type GNU plot space packet delivery ratio, that is for pdr.plot, which will produce our comparison between MTS and the STBG scheme. So we have to deliver 98% packet delivery ratio. In existing system they use 80%, they use 92% of packet delivery ratio. So our system deliver high packet accuracy than the existing system. Thank you for watching.